The Briggs and Stratton fuel tank has three key functions. The first is to store fuel for consistent engine operation. The second is to supply fuel efficiently to keep the engine running smoothly. And thirdly, to keep contaminants out to prevent clogs and damages that can reduce the performance or cause failure of the engine.
The Briggs and Stratton fuel tank is built to handle tough conditions while ensuring reliability. It must be fuel resistant to prevent degradation over time and impact resistant to withstand vibrations and accidental knocks. Corrosion resistance is crucial to stop rust and chemical damage, whilst its lightweight design makes handling and installation easier. Proper seal prevents leaks, ensuring fuel efficiency and safety. And lastly, thermal stability allows it to perform well in different temperatures without warping or weakening. Together, these properties ensure a durable and efficient fuel system.
The clean, straight edges on the tank's sheet metal suggest shearing was used. The lack of burrs, sharp corners, and no signs of melting point to mechanical shearing rather than thermal cutting. The tank's smooth, curved 3D shape and uniform thickness and seams show that it was likely made using deep drawing. Around the perimeter, the precise and consistent bends in the metal flanges are typical signs of controlled bending. Finally, the clean, sharply defined holes for the fuel outlet, vent, and mounting points are clear evidence of piercing using a punch and die, not manual drilling.
After material selection, the fuel tank is primarily made from sheet forming operations. Firstly, large metal sheets are mechanically cut using shearing to create the flat sheet metal pieces that make up the fuel tank's rough outline before forming into their final 3D shape. These metal sheets are then transformed into the top and bottom halves of the fuel tank via deep drawing, where a punch and die press the flat tank blank into a deep hollow shape. The edges of each half are bent outward to form flanges, a process achieved through bending. These flanges are designed to facilitate the assembly of the two halves during the subsequent joining process. Piercing creates openings for the fuel filler neck, fuel outlet, vent hole, and mounting holes. In this application, these holes are formed by forcing a shaped punch through the workpiece into a shaped die. The fuel filler neck and outlet fittings are made using extrusion before machining to create the thread. Finally, the outer layer is painted to prevent rusting and corrosion.